Hi there, I'm John Moncrief, the training lead for the education department here at SideFX. Today I'm hoping to expose some of you to a few new workflows in Houdini 18 and hopefully spark some interest for you to go and play with some of these new SOPs-based effects tools that we have in this release. It's quite a bit of fun. There's a lot of really interesting new tools that allow you to do very creative things, very artist-friendly and straightforward workflows. So before we get started though, I think it's pretty important that we actually know what SOPs-based effects means and why basically at SideFX we made the shift to include these tools on the SOPs side of things. So let's look into that for a second. So in recent releases of Houdini, there's been a shift towards SOPs-based workflows for many common effects solutions, right? Traditionally, this method of working would have been done in a DOPS context with a DOP network, and all of that still exists. None of that's been taken away. What we've done is we've added this additional way of working that provides a solution for many artists and studios to create super high quality effects without having to jump around into different contexts of Houdini, without a deeper understanding and knowledge of exactly how DOPS works. But somebody with a good eye that has a good eye for effects that has access to Houdini Core, for example, can still go in and make really nice looking effects without having to worry about some of the complexity that DOPS brings with it. So let's dig a little bit deeper into what it is we're talking about here. So first off, it's good to know what the overall philosophy is and kind of why we've included this new way of working. And really, like I said before, it's all about artist-friendly tools that allow a greater number of artists to do more art directable work, right? So one of the things that happens when you move effects over into SOPs, the SOPs context, is that it unlocks the creation of effects for a whole new artist, right? This means that these effects tools we're going to talk about today are available in Houdini Core. That's right. So all of the things we're going to discuss, like fire, smoke, cloth, hair, grain, soft bodies, destruction, all of that stuff will work with a Houdini Core license. Now, I did mention that all of these things have been moved into SOPs. It's not that they've moved, as I said. There's just an additional way of approaching them. It's done in SOPs, and that's what's available from within the Core license. If you do find that you need to have a more complex workflow that does require you diving into DOPS, then you can easily hand that file to somebody with an effects license, and they can dive inside of the HDAs that make up these tools and begin to unpack them and really go in and do anything that they need to do on a higher technical level. So all that functionality is still there. So the second thing that happens whenever you bring dynamics into SOPs is that you get a little bit easier learning curve. Okay, so that learning curve drops significantly when you're working with these tools in SOPs, and mainly it's because of a more compact and efficient approach to the way that the parameters are exposed to the artist. So it's less time jumping around and looking for the right parameter to tweak to make something happen, and more time actually directing your simulations to look the way that you want, because the sliders that you need, the parameters that you need, have already been built into a highly functional HDA and promoted to the user level for you as an artist. So you can just go in and find the key things that you need to have the most impact and the most art directability for that particular situation right there on the surface of the node. And we'll see that when we dive into Houdini here in a minute. Another thing to mention while we're talking about the philosophy of this SOPs-based approach to effects is that the SideFX Labs team has done some incredible work to ensure that getting the results of all of these things that we're talking about, these SOPs-based simulations, getting them out of Houdini as data that you can use in your game engine of choice. So making sure that that piece is smooth and works without Houdini engine, but just getting data to disk that you can actually, ingest into your game engine and take advantage of. For example, the Vertex animation texture tools, which basically export a mesh and some textures to be used with a real-time material that it plays back these animations for all of these types of effects in a very efficient way. That tool has been greatly improved to add many new features and some expanded capability for Unreal, Unity, Lumberyard, CryEngine, and many others as well. Of course, there's always the easy export tools for creating like FBX bone-based results from rigid body simulations. And of course, sprite sheets with customized data stored in color channels that can be used inside of shaders and other engines. So all of that as well is something to consider. So what are the key tools that we're talking about here? What's included in this new SOPs-based workflow? Well, we start with Vellum, which is our character effects package, right? Capable of creating efficient, fast cloth, hair, grain, soft bodies, mainly things you would find for character effects. Then there's also the destruction tools. The rigid body simulations are all based in the Bullet solver. These tools have had quite a bit of attention in Houdini 18. There's all kinds of new workflows, including like guided simulations, which is what you're seeing in this image here on the left. It's a lot of fun to play around with. There's also more realistic fracturing and chipping algorithms, and just a lot more tools that have been set up to make this process easier for artists to get into and understand exactly how things are being set up. And we'll take a look at some of that as well. And then let's also not forget about the highly efficient new sparse Pyro solver, a brand new shelf added in Houdini 18 called Simple Effects that is all shelf tools that will create existing node networks for you that are all SOPs-based workflows for effects. And we'll take a look at that as well. So here we are inside of Houdini, and the first thing that I want to point out is the new Simple Effects tool shelf. So up here on the top, just the third one from the end, if you click on that, that is the Simple Effects tools. So I'm going to set up a couple of things here, just really simply. Let's do a cloth. So this simple cloth is going to be a flag. Let's make a flag so that it looks just like the icon there. So I'm just going to lay down a grid. And we're going to resize that grid just a little bit. We'll make it 2 meters by 4 meters. And we want it to be, oops. There we go. Let's make it the other way around. Sorry, let's do 4 by 2. Awesome, there's my flag. It might be a little bit long. Okay, perfect. So there's my flag. And really now I'm gonna push it up so it's not sitting right below the grid, just a little bit there. There we go. Awesome. Maybe a little bit more. Okay, so now that we've got this, I'm gonna select the grid and I'm gonna hit the Simple Cloth tool. And it asks me down here to select the objects that I want to turn into cloth. I can grab that grid, hit enter. It says select a collision object, and I don't really have one at this point, so I'm just going to hit enter. And there we go. So all of a sudden, this has been turned into a dynamics cloth. How do I know that? If I hit play, it will start to fall, and it will fall indefinitely because there's no ground object. Now, let's take a look at what the shelf tool actually did, because it doesn't look like anything happened over here inside of SOPs. Let's go back up to the object level. Now what Houdini has actually done here is it's turned off your original source geometry, and it's actually imported your items into a new directory over here and used this object merge to link back to that object that you had, which was the grid, right? So this grid one. And it just does that so that you can preserve that original geometry if you want to use it somewhere else. If it was a character that you didn't necessarily want to manipulate this way, you could actually just reference it into this now cloth simulation and have it be a collision object or anything else. So here we go. We've got our cloth falling. Now, how do we make the pole and attach it to the pole? Well, first off, what we need to do is make the pole. So I'm going to go ahead and just make a tube. And we'll make it maybe a little bit taller. Make sure that we're touching our flag. And of course, it needs to be quite a bit smaller. And I'm going to go ahead and just turn it into a polygon 2. And we'll scoot it over so that it's right over here by the flag. Okay, awesome. Very good. And we'll give it some end caps just so it's closed off. So what do I do with this now? Well, I need it to be a collision object so that it can be introduced into my simulation before I can attach it. So this third input over here on the far right-hand side of this SOPs-based workflow for Vellum is the collision. So I can put it over here. Now it's been made into a collision object, but I can't see it, right? And I can't see it because I need to merge it into the final output of our cloth. So I'm just going to do a quick merge. And we'll lay it down here. and merge these two things together. And now I can see, hey, there's my flag and the flagpole, just like I need everything to be, right? So how do I actually attach the flag to the flagpole? Because right now it's still just falling and hitting the ground. Well, we do it using a Vellum tab, V-E-L-L-U-M, Vellum. And what we want to do is we want to do a attach to geometry right here, which is this first option. So I'm going to do that, and I'm just going to plug it in before the solver. So I'm just going to scoot these nodes down and plug this in right here. Notice when you hover over, all three connections are smart enough to automatically connect up for you. So you don't have to worry about clicking and dragging each one to be able to connect them up. Awesome. So here's my Vellum attach, and as I can see here, I've got all kinds of new constraints that have been added to my flag. And if I click play, well, it still doesn't quite behave like I expected it to. Right now, I've got every single point on my flag being constrained to the pole, and really all I want is this set of points on this closest edge of the flag, right? So let's go ahead and set up our target geometry, which is going to be the actual flagpole. So it is primitives that we want. So which primitives do we want to attach to? Well, it's probably going to be these two here that we're going to pick for our target. So let's go ahead and click on this little selector icon over here, and then we can actually come up here and select those two primitives and hit enter. And when we do, Houdini automatically updates that for us. The next thing that it asks for is, hey, well, if that's not, you don't want every single point, then which points do you want? Well, that's the geometry that I want to constrain, and that I do want to use points. Click my little selector button and select just these points on this far side here. Now when I hit enter, you can see the constraints now only show from that far edge. And when we click play, it behaves much more like a flag would. Now, one of the things that you were given as a part of this nice shelf tool set was this cloth post process. And cloth post process has the ability to come in here and do subdivision after the simulation. And what that means is it allows you to add resolution post simulation. So the simulation doesn't necessarily get any slower, but you do have more resolution in the final look of the object when you're done. You know, one thing that would be really nice here would be if I could add just some basic wind to this, you know? So if I come up here and look at the solver, there's a forces tab. And one of the things the forces tab has is wind. So I can do that. I can come in here and add, say, some wind. And now all of a sudden my flag is behaving as if it's blowing in the wind. How cool is that? So what I want to do is actually sort of take you under the hood of what this setup is right now. And I think it's okay for us to spend a little more time on this first example, because this is really the same workflow for all of the tools that you're going to use on the SimpleFX tool shelf. So if you are a Houdini core user and you've got this far, and you still again, you have a ton of different options for art directing this. I don't have time to go into all the different stiffness and bend constraints, the different forces that you can add. But the important thing about that is, notice that this right now, this cloth solver here, if I double click on it, I go into an area that's more than one layer deep. Actually, I've gone 3 layers deep into the network, into this little box called forces. Now this forces network is part of the Houdini digital asset, or the Vellum solver node that you're seeing back here. And what this allows you to do is to add forces to the underlying DOPS simulation without having to actually dive into DOPS and know where to plug it in the right place at the wrong time and that kind of thing. So number one, all of the controls I need for this simulation have been gathered up here into a nice clean interface so I can find them. Now, I want to add some forces. I just double click on it and I can add let's add a pop wind. It'll tell you right here, wire pop forces into force output. So you're even getting help as you go along here. So I'm just going to wire in the pop wind. And this pop wind I'm going to use, let's say, to push it in an up direction. So almost as if there's wind coming up from the ground, pushing the flag up into the air. And we're also going to add a little bit of noise. Let's add some noise in there too. So there, I've added a new force to my simulation. We'll click play to see what happens. Let's get our display flag down here. Hey, there you go. So my new force has actually taken effect. So I was able to add in a force inside of my DOPS simulation without having to actually look at my DOPS simulation. How is that possible? Well, it's possible through the use of dive targets. This HDA is set up so that when I double click on it, it takes me these 3 layers deep and drops me in this nice, clean, friendly area where it tells me exactly what to do. So if you're a core user, that's where your functionality stops. If you're a Houdini effects user and you need to take the simulation that a junior artist or that anybody else may have worked on and really tweak it and pump it up and use some of the more highly detailed solvers, micro solvers, and things of that nature, you can just right click here and go allow editing of contents. That, of course, cracks open the Houdini digital asset, and now you can double click on it and notice that, hey, this is actually what's happening underneath the scenes here, okay? And then from here, somewhere in here, oh my gosh, there is a solver, and then inside of that solver, if we can find it real quick, there we go, there's the .NET, and inside of that solver is a forces tab, or forces node, and really what it is just another place where we can drag in our forces. And if you look, this is where we added our pop wind with our noise, right? So what this SOPs-based workflow has saved me from is understanding this underlying network, understanding the sub-network inside of it, which is the .NET, understanding how the forces are wired into that Vellum solver. All of that stuff is not necessarily important to get up and running quickly and to start making iterations on your simulation. So that's what you can accomplish when you're working inside of the SOPs-based layout. So let's go ahead and I'm going to lock that back by right-clicking on it and saying match current definition, and you'll notice the little red lock goes back to gray. Now, if you're an effects or a core user at this point and you double-click on this, the dive target is in effect, and now you can start adding all of your different forces that you need right here. Okay, so that is kind of a quick overview of the philosophy of how these DOPs or SOPs-based effects are actually happening, right? And you can see the simplified nature of what's happening. Instead of knowing all the different parts of a DOP solver, you now can just jump up here and start playing with the parameters that are named correctly in a very common place. So let's play around with another thing. And I want you to notice this time around the similarity in the thought process of the workflow when we do this. So I'm going to just take, let's make a box this time. And I'm going to make sure that box is, let's make it, oh, I don't know, 5 units tall. And let's make sure that it's sitting on the ground. So instead of just randomly coming up here and trying to eyeball it or using a bounding box expression, because I don't really like trust myself writing expressions, I'm bad with syntax. There's a really nice node here now called match size. And it's got some other functionality to it as well that includes matching size. But one of the things that's really handy is this justify. In the justify Y direction, I'm just going to pick the minimum, and it takes the minimum of the box and pushes it up so that it is justified on the base of the construction grid. So no more expressions to write, no more eyeballing it. I know that it's sitting directly on the ground now. Awesome. So I can come up here and grab this box, and I'm just going to say, hey, let's do a simple fracture here. So I'm going to click on simple fracture. And it says select any collision object if there is one. There's not, so I'm just going to press enter. Houdini goes through and does its thing here. Boom. And we can instantly see that we've got all of our fractures made for us. We can see that here with the little white lines. And we notice, please, the workflow here that's done the same thing. Our original box that we created, if we dive inside, nothing has been added to it. Nothing has been changed with that original source geometry. It's just been made invisible so we don't see it. And then inside of this box one fracture, it's been referenced with an object merge. So again, the original object being protected, and now we're going to do anything that we want to with this copy of it here, or reference of it here inside of this box one fracture geometry. So again, notice it's just laid down for you the nodes that you're going to need right off the bat to start working with this piece of geometry. So we've got our solver here, and we've got a configure node here. And we've got our material fracture, which is happening right here. So the fracturing happens in 2 levels. And if I want, I can just come in here and start changing the amount of fractures. So I'm just going to go down to the 2nd level now, and we'll up it as well. We'll make it 10. So you can see these secondary fractures that are happening based off of the original shapes. So I've got a decent little set of fractures going here. I'm going to crank up my secondary fractures just a little bit more. Okay, awesome. And while we're at it, we can come over here to the chipping tab, and I'll enable chipping. And you'll be able to see what that looks like here in just a second. You'll notice right off the bat what the chipping has done is it's found the sharper edges. If we look at this here, and it's actually just adding more detail around those sharper edges so that when those edges come in contact with a collision object, the ground or whatever it is, the chipping will be more detailed on the edges. Of course, we also have the ability to add all kinds of things like edge detail. Now watch what happens when we add edge detail. See this very straight cut line that we have here? Edge detail will go in and it will actually add some variation to that cut line. So it takes just a second. We upped our number of fractures, so we can expect that the edge detail is going to take just a little bit longer, but there we go. You can now see that the line that was originally straight is now sort of curvy. It looks a lot more like a piece of concrete would. And keep in mind, all of this that we're playing with right now is just the concrete. You also have options for glass fracturing, wood fracturing, and any kind of custom fracturing that you want to set up can all be done right here from within the SOPs-based workflow. So I've got my pillar here. This is great. And what happens if I just click play? Well, something very similar to what was happening when we clicked play with our flag, right? Let's move our display flag and selection down here to the bottom of our network, right? So it's just falling because there is no ground plane. Well, let's add one. So I'm going to come over to the solver, and I'm just going to add a ground plane. So under collisions, under ground, I'm going to choose ground plane. And now I've got a ground plane, and if I hit play, nothing happens. And the reason nothing happens is because by default, when we make this fractured object, one of the things that happens is glue is applied to it. So glue is a constraint that holds the pieces together. I can come under the Constraints tab, nicely organized right after I've done my adjustments to the solver. Under the Glue tab now, I can take that strength and let's make it 0.01. So very weak bonds now between these individual pieces. In fact, the force of gravity is probably going to be enough to collapse it. Yes, it is. There it goes. So the 9.8 meters per second of downward force that we have created, that is gravity, is actually just pulling the thing apart because there's not enough strength holding those individual pieces together. And of course, they all fracture up as soon as they come in contact with the ground. Okay, so if I wanted to add an extra object in here, that would be the collision object. I could do that and just wire it right into this input here. But more importantly, I kind of want to demo the new guided fracture option, which is this far right input. So I can actually have one animation guide the behavior of my destruction. So let's create something like that now. So I'm just going to make a new box. And let's go ahead and just make it a little bit taller here than the original. We'll scoot it up. And let's make sure it's got plenty of divisions in it. So let's make sure it's a polygon mesh. And we'll make this 8 divisions by 16 divisions by 8 divisions. Let's actually make this a little more. Yep, awesome. And I'm going to use a bend node right after it to sort of manipulate what's happening here. So here's my bend node. And let's just see what the bend node is doing by default. Yeah, that's not quite what I want it to do. So I'm going to go ahead in here and set the capture region for my bend node. There we go. And now we've got a nice bend that we can use. So this is the bend. I'm going to go ahead and animate this bend a little bit. So we're going to say this is at 0. And I'm going to alt-click that. That's going to make a keyframe. And I'll take my keyframe up to, let's say, 48. And at 48, I want it to be bent almost all the way over here. Awesome. And we'll alt-click that. So if we look back at just what we've got here, it's this animation. Okay? So I can take that animation and have it influence what's happening over here. Now it's already kind of falling to the left, but it's catty corner, and you can tell it's not very particular in how it's falling whatsoever. So if I really wanted to art direct this in a way that was specific, I could come in here with my guided simulation, plug it into this last input, and when I hit play now, well, when I hit play now, we get the same result, and that's because we have to turn on the guided simulation inside the solver. So I come back to the solver, And look, there's a tab called Guided Simulation, and I just click on Use Guides, and now watch the behavior of what's happening with my simulation. It's very, very much following exactly what's happening. In fact, it's following it to a point that it's not even behaving physically accurate. It's just forcing itself to follow as best it can what's happening with that curve, or the bend, right? So we have adjustments for that too. So we come over here into where the solver is under that Guided Simulations tab, and we have a strength of the guide that we can change. So I'm just going to make the strength a little bit smaller. We'll make it a 0.5 and see what happens. So we're starting to let go of the pieces a little bit earlier here. We're starting to get break in the middle, which we didn't have before. We can also change what's happening with the distance as well. So let's make the max distance that it will travel beyond the bend a 0.5. So the bend comes into play, and as soon as any piece gets beyond 0.5 of that strength, then it begins to lose. So we still have the guide driving the simulation, right? We can change its strength again to 1, and we can even lower the glue a little bit more if we wanted. So I can come back over to the Constraints tab, and let's make that glue way small. It's a way that you art direct your simulation based off of another animation that exists in your scene somewhere. So guided simulations, another really great way, again, very simple to set up. And let's see what we're bypassing here. If I double click on this, actually I'm drawn right back into the same place where I can add forces. So if I wanted to add a wind, right, I could add my pop wind because it says put pop forces here. And let's give it a really strong upward blast of 10 meters per second. And now whenever we click play, the pillar gets blown up by this new wind that we've added. But the same way that we were working with the flag, we can see here that we're actually inside of another DOP-net, which is inside of another solver, which is inside of this node here. So instead of diving and digging around through all of those different nodes to find exactly what it is that you want, those things have been packaged up for you and brought up into easy to navigate tabs. We're just going to lay down a little null. We'll plug it into the output here. If we look, we can see that's our actual geometry output. So that's what we want. And we would just call this out. And then we can come over to the out context. And right here in this area, we can do VAT, which will give us the Vertex Animation Textures tool. And the Vertex Animation Textures tool actually allows you to spit out a geometry and some other images that are used inside of a shader for whatever it is engine that you're working on. And really, it's pretty much done for you. Most of the work is done for you. If you come over here to this SOP path and point that over to your out node, you'll be able to pull in that geometry. Remember, that's here in the box fracture. All right, awesome. So now we've got our geometry pulled in, which is fantastic. Oop, it broke. There we go. Cool. So once we've got it brought in here, then we just have to tell it, hey, what are we exporting? Well, this isn't a soft body constraint, so that's not exactly what we want to do. We can just click on that and choose rigid or fluid or sprite. Fluid would also apply to, of course, Pyro. But you just pick whichever type of simulation it is that you're exporting. And again, notice how nicely these things match up with what's indicated over here on the simple effects shelf. So once you do that, you just pick your engine that you want to export to here. They're Unreal, Unity, Lumberyard, CryEngine. There's some others in here as well. And then you say initialize for engine, and it tells you, oh, hey, Unreal uses the default settings. Cool. No problem. And you hit render, and you're off to the races. The other thing that you want to do after that is come over to the user interface dropdown. And at the user interface dropdown, you can pick normal. And this will actually, which is pretty cool here, give you the shader code that you need to just copy. I'm just going to do a Control-A, Control-C. So I can just copy that and then paste that inside of my material builder in whatever my game engine is. And it will automatically build the shader for you, or the shader function for you, depending upon how you set up this particular node. But again, you don't have to know all of this information. It's going to build it automatically for you. So we're providing you the easiest possible route to use these very easy and straightforward tools so that you can get going quickly and get some effects going inside of your particular game engine, no matter what it might be. So I hope you've enjoyed this, and I hope it's given you some inspiration to go forth and start exploring the workflow between using some of these more SOPs-based effects simulations and the new Vertex Animation Textures tool to actually export the stuff for you and get it over into Game Engine directly. All right, thank you.